NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new. More mysterious, more beautiful than humanity's dreams.
And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
When the James Webb Space Telescope was launched, scientists expected breakthroughs. They expected sharper images, deeper views, and answers to questions humanity has been asking for generations. What they did not expect was to find something that appears to challenge some of the most fundamental assumptions about the universe itself. And yet, that is exactly where we are now. Buried within recent James Webb observations is a discovery so strange, so difficult to explain, that many scientists initially questioned whether it was even real. Multiple teams rechecked the data. Instruments were recalibrated. Assumptions were tested again and again, but the results stayed the same. Whatever James Webb detected is not supposed to exist, at least not according to our current understanding of physics and cosmology. To understand why this discovery is so unsettling, we first need to understand what James Webb was built to do. Unlike previous telescopes, Webb sees the universe primarily in infrared light. This allows it to peer through cosmic dust, look deeper into space, and therefore further back in time than ever before. Because light takes time to travel, looking farther away means looking earlier into the universe's history. In simple terms, James Webb is a time machine. It shows us what the universe looked like, not millions, but billions of years ago, close to the moment when the first stars and galaxies were forming. This is where the problem begins. According to long-standing cosmological models, the early universe was a chaotic, turbulent place. After the Big Bang, matter needed time to cool, clump together, and form stars. Those stars then had to live and die, creating heavier elements. Only after several generations of stars could large, complex galaxies begin to take shape. This process was thought to take hundreds of millions, even billions of years. The timeline seems solid. It was supported by decades of observations, simulations, and theory. James Webb, however, has been quietly tearing that timeline apart. In some of its deepest field observations, Webb detected massive, well-structured galaxies existing far earlier in cosmic history than they should. These galaxies are not small, faint, or primitive. They are large, bright, and surprisingly mature. Some appear to contain billions of stars arranged in organized structures at a time when the universe was supposed to be too young for such complexity. In other words, Webb is seeing galaxies that look fully grown when, by all expectations, they should barely exist at all. At first, scientists assumed there must be an error. Perhaps the distances were miscalculated. Maybe the redshift, the stretching of light caused by the expansion of the universe, was being misinterpreted. Teams around the world independently analyzed the same data. Different methods were used, different assumptions were tested, and yet, again and again, the conclusion pointed in the same direction. These objects really are that far away, they really are that old, and they really are far too massive for their age. This raises an uncomfortable question. If these galaxies exist, then either the universe evolved much faster than we thought, or our understanding of how galaxies form is fundamentally incomplete. Neither option is comforting, but the story does not end there. In addition to these impossibly early galaxies, James Webb has also detected chemical signatures that add another layer of mystery. Webb's instruments can analyze the light from distant objects and determine their chemical composition. This allows scientists to identify elements like oxygen, carbon, and even more complex molecules. The problem is that some of these early galaxies appear to contain an unexpected abundance of heavy elements. Heavy elements are forged in the cores of stars and spread through space when those stars explode as supernova. This process takes time, a lot of time. The presence of these elements so early suggests that stars were forming, evolving, and dying at an incredibly rapid pace shortly after the Big Bang. Faster than our models predict should be possible. It is as if the universe skipped several steps in its own development. Some researchers have proposed that star formation in the early universe was far more efficient than we assumed. Others suggest that massive stars may have formed almost immediately after the Big Bang, living fast and dying young, enriching the cosmos at an accelerated rate. These ideas are not impossible, but they require significant adjustments to existing theories. Adjustments that ripple outward, affecting everything from dark matter models to the estimated age and expansion rate of the universe itself. Then there is another possibility, one that makes scientists particularly uneasy. What if our measurements of distance and time are wrong? Some researchers have suggested the idea of direct collapse black holes. Massive objects form from the collapse of enormous gas clouds without first forming stars. This concept has existed in theory for years, but Webb's observations may be the first hint that such objects were not just possible, but common in the early universe. If that is true, it would explain some of the anomalous brightness and mass seen in these early structures, but it would also raise new questions. What conditions allowed such collapses to occur so frequently? And what does that mean for the evolution of galaxies that formed around them? James Webb is not just giving us prettier pictures, it is exposing the limits of what we thought we knew. The implications extend far beyond academic debate. Our understanding of galaxy formation affects how we interpret dark matter, the mysterious substance that makes up most of the universe's mass. It influences how we model dark energy, the force driving cosmic expansion. It even affects estimates of the universe's age. If structures formed earlier than expected, some of these values may need to be adjusted. There is also a deeper philosophical impact. For decades, humanity has told a story about the universe that begins with simplicity and slowly builds complexity. Webb's discoveries suggest that complexity may have emerged almost immediately, as if the universe was primed from the start to create structure. This raises uncomfortable but fascinating questions. Was the early universe more finely tuned than we believed? Are there unknown physical laws that operated more strongly in the past? Or are we missing an entire chapter of cosmic history? Some researchers caution against jumping to conclusions. Science advances by careful verification, not speculation. Future observations, both from James Webb and from upcoming telescopes, will be crucial. Additional data could clarify whether these objects are truly as massive and old as they appear, or whether subtle effects are skewing our interpretations. But even the most cautious scientists admit that something profound is happening. James Webb is forcing cosmology into a period of re-examination. Textbooks will not be rewritten overnight, but they are no longer as stable as they once seemed. Perhaps the most unsettling aspect of all is that this may only be the beginning. James Webb is still early in its mission. Many of its most ambitious observation programs are ongoing. As it continues to peer deeper into space and further back in time, it may uncover even more objects that defy explanation. Each new data set has the potential to either resolve these mysteries or deepen them. And history suggests that when powerful new instruments reveal unexpected results, science does not simply adjust at the margins, it transforms. In the past, discoveries like the expansion of the universe, the cosmic microwave background, and dark energy reshaped our understanding of reality. James Webb may be ushering in a similar moment, a moment when we realize that the universe is not just stranger than we imagined, but stranger than we are currently equipped to explain. For now, scientists are doing what they always do when confronted with the unknown. They are questioning assumptions, refining models, and gathering more data. But beneath the careful language of research papers and press releases, there is a growing sense of awe and unease. Because whatever James Webb has found, it is telling us that the universe grew up far faster than we thought, or that our story of cosmic origins is missing something essential. Either way, we are being forced to confront a simple truth. The universe is not obligated to make sense to us. And sometimes when we build better tools to observe it, it reveals just how incomplete our understanding really is. James Webb did not just find something unusual. It found something that challenges the foundation of modern cosmology, something that should not exist. And yet, there it is, written in infrared light across the deepest reaches of space. If you enjoyed this video and want to stay updated on the latest discoveries from the James Webb Space Telescope and beyond, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss what the universe reveals next.